Hello friends, this video on P block elements part 2 is brought to you by examfear.com. No more fear from exam. Now we'll talk about some of the properties of the P block elements. In this we'll see that the last electrons enters the outermost P orbital. That is something we have seen. We have defined this, that P block elements are the elements where the last electron enters the outermost P orbital. Helium is the exception here. And if you see P block element, P orbit looks like this. We have seen the structure of this. If you have doubts, you can watch the video on the chapter where we discussed about the orbitals. So we have Px, and let's suppose this is Py, and then we have Pz, right? So 1, 2, 3, 4, 5, 6. So P orbital can hold at the max 6 electron. So if the last electron enters these orbitals, I say it is a P block element. Helium is a exception. In the helium, it is 1s2, that is my electronic configuration, right? So the last electron enters s orbital, but since the helium property is very much similar to my neon argon, helium is also kept in P block elements. So if you see, the P orbitals can accommodate 6 electrons, as I told. 1, 2, 3, 4, 5, 6. Let me put a dot here. 1, 2, 3, 4, 5, 6. So helium can accommodate 6 electrons, right? And thus we have 6 group of P block elements. So there's a good question, why we have 6 group, why we don't. For example, S group, we know that there are two groups, S block, right? My group 1 and group 2. But P block, there are 6 groups. 1, 2, 3, 4, 5, 6. The good question is, why there are 6 group? 6 group because the P orbital can accommodate 6 electrons. In this case, I have P1, only 1 electron in the P block. This is P2, 2 electrons in the P block. P3, 3 electrons in the P block. P4, 4 electrons in the P block. P5, 5 electrons in the P block. And here it is P6. Helium is the exception anyway. You can ignore the helium. Apart from this, everything is P6. And that's why we have 6 groups, and the number of group is 13 to 18. Correct? Please note, it is group 13, 14, 15, 16, 17 and 18. It is not group 5, 6, 7, 8, 9, 10. A lot of students get confused. It is group 13, 14, 15, 16, 17 and 18. Okay? And if you see, the valence cell electronic configuration is in this form: ns2, np, 1, 2, 6. This will decide which group it is. If it is 1, it will be in 13 group. If it is 2, it is in 14 group, right? If it is 3, it will be in 15 group. It is 6, it will be in 18 group. So best way to remember this is group 1 belongs to group 13. Why? See, 13, right? You subtract 10. Subtract 10 and then subtract this 2. Because it is in P block, there is a 2 also, right? So 2, sorry, let's add 2. And then you add this value 1 to 6, whatever you want. So this is the formula. 10 plus 2, 12. You add 12 to this. For example, it is group 1. Sorry, the last only 1 electron in the P block. 12 plus 1, group 13. Only 2 electron in the group, in the P orbital. 12 plus 2, 14. 3 electron in P orbital. 12 plus 3, 15 group. 4 electron in the P orbital. 12 plus 4, 16. 5 electron in the P orbital, right? 12 plus 5, 17. 6 electron in the P orbital. 12 plus 6, 18. Correct? There is a difference of 12 in this. Okay. And one more good part about this P block element is a very unique part, that you have metals, you have non-metals, and we have metallites. All these 3 exist in this P block. So if we talk about the metals, we have aluminium is a metal, right? We have gallium is a metal, indium is a metal. All these are metal actually. If we talk about metallites, I have boron is a metalloid, my silicon is a metalloid, all this brown color, germanium, arsenic, these are all metalloids. Talk about non-metal, my nitrogen is a non-metal, sorry, let me do it some other. Nitrogen, oxygen, fluorine, chlorine, bromine, all these are non-metal. Correct. So we have metal, non-metal and metallite. We'll discuss about this in detail in this p block element. The only block which has all three metal, non-metal and metalloids existing is p block elements. Since we have now, as I told, we have metals, we have non-metals, we have metalloids all together in this p block element, there is a lot of variation in the physical properties. So if you see the physical property of boron and physical properties of neon, there is a huge difference. If you talk about the physical property of carbon and physical property of fluorine, there is a huge difference. There is a huge difference in the physical properties of elements in this group. And also the first member of each group differs from the remaining members. We'll see that the first member is always special. The first member is always special. We'll see special behavior of nitrogen. We'll see special behavior of oxygen, fluorine, and neon. Right? Let's see how they look before we even start. So in this group 13 and group 15 is already we have covered in class 11th. Group 15, 16, 17, 18 will be covering. Nitrogen looks like this. It's in almost the gas form. Phosphorus, it has various electrons. We'll discuss about this. So this is how it looks, all these elements. My arsenic, antimony and bismuth all are solid and has because shining surface. Oxygen is again, you can get oxygen in the liquid form and oxygen in the gas form also. Then you have sulfur, we'll see the electrons of sulfur also. So we will discuss about all these. We see the bromine, it looks like it is liquid red. We see all this noble gas elements, they're all gases with different colors. You see iodine is black color. Chlorine is also white, almost transparent liquid. So we'll discuss about all these elements now. We'll start with group 15, but before that we'll discuss again some of the common trends in the p block element. We've discussed that in class 11. We'll just do a quick repeat. So if you see, this is what we have discussed. If you go from left to right in the periodic table, the electron gain enthalpy increase. Electron gain enthalpy is nothing but the amount of energy released when an isolated gaseous item accepts an electron to become monovalence gaseous ions. And generally it's electron gain enthalpy, that is amount of energy is released, but sometimes even energy is required. Right? For example, fluorine will become F minus, fluorine becomes C minus. So in this case they will generate some energy, they'll give some energy. Delta H is something negative. They will emit some energy, right? So this is a isolated gaseous item. This is isolated gaseous atom, and this will accept an electron to become my gaseous ion. And this, in most of the case, it releases energy, and that's called electron gain enthalpy. And this increase actually, fluorine has a maximum value because fluorine wants to be stable. Chlorine also has a good value, but if you talk about oxygen to O minus, I doubt it will have a good value. Anyway, so this value increase if you go from left to right. Also, if you go from bottom to top, this value increase. Similar trend for the ionization energy. Ionization energy is nothing but, or ionization enthalpy is nothing but amount of energy required. So this is emitted generally, and this is required. This is the reverse trend actually. To remove one electron from the atom. So I have an atom, I want to remove one electron. For example, I have Na, I want to make it Na plus. I want to pluck one electron from Na. Right? This is my ionization enthalpy. This is the amount of energy required. This is typically amount of energy required to remove one atom. So remove an electron from the atom. The next is the metallic character increases in this fashion, non-metallic character increases in this fashion. We have discussed a lot about this. Atomic radius, if you go down the group, the atomic radius increase. If you go from right to left, the atomic radius increase. Electronegativity, if you go from left to right, the electronegativity increase, and if you go from bottom to top, electronegativity increase. I have not discussed this in detail now, but you can watch the previous videos on periodic table trends where we've discussed these things in details, why it behaves. Right? This is just a recap. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.